Okay, in this page, we are asked to find the interval at which g of x is decreasing. And here's the graph of g of x. We notice that if we trace it, it's from the left side, it is increasing until it reaches the relative maximum, and then it decreases until it reaches a relative minimum, and then it starts going back up and it doesn't come back. So at what interval is g of x decreasing? The relative maximum is right here at negative 1.646. So on the x-axis, well, let's mark that point. That is negative 1.646. And then it stops decreasing here at 3.646. So let's mark it here on the x-axis. So we know that the graph is, this is the right boundary, where the graph stops decreasing, and the left boundary where it starts in decreasing is right here. So that means in this section or in this region, the graph is decreasing. Okay, so how do we describe that interval? That is from this point to this point. So we describe this interval as, if I have numbers here that I will call x, I will say that x is on the right side of negative 1.646 or negative 1.646, negative 1.646 is on the left side of x, and x is on the left side of 3.646. So x is less than 3.646. This is the interval where g of x is decreasing. Okay, let's move on to this one. The graph of g of x and its table are shown on the left. So here's the table, and there's the graph. Okay, find g of 3. So to find g of 3, we want the x to be equal to 3. So on the table, we look at the x column, and we look for x is equal to 3. And we notice that the y value is negative 14. That is g of 3. So g of 3 is negative 14. G of negative 3, so we look again for negative 3 on the x column, and it's right here. Therefore, g of negative 3 is 40. G of 1, so here's 1. G of 1 is 20. G of 5, so 5 is right here. So we'll put here g of 5 is 0. And g of negative 1, which is up here, is 54. Okay. All right, so let's move this up. What kind of function is g of x? When we notice from the graph that it is a cubic function. So the lowest possible degree is 3. So we'll say that it is possibly a cubic function. At what intervals does the graph increase? Well, it increases on the area where it's not shaded by green. So the area that's not shaded by green is, there are two there's two intervals. So the left side, on the leftmost, it is x is less than negative 1.646. And on the right side, it started going up at 3.646 and then keeps going up from there. So it goes up when x is greater than 3.646. At what intervals does g of x decrease? Well, we already wrote that down, so we'll just repeat it here. It's going to be at negative 1.646 is less than x, is less than 3.646. Does the graph have an absolute maximum? Well, if we trace the graph, it is starting from below the x-axis, then goes up, comes back down, and then keeps going up from there. And therefore, we cannot find an absolute maximum. We will also not be able to find an absolute minimum. So our answer here should be none. No minimum as well. But there's a relative minimum and a relative maximum. So the relative minimum is, okay, if you want the value of the relative, okay, we want minimum first. So the value of the function that gives us the minimum is this value. This is the value of the function, the y value. So does g of x have a relative minimum? Yes, and that is negative 17.04. So we can say that this is the minimum value of g of x. Now, if we want, we could say this the minimum point is, or the relative minimum point is 3.646, comma, negative 17.04. Okay, now for the maximum, and it's gonna be this one. This is the maximum. Oops. The maximum is 57.04. So let's put that here. Relative maximum is 57.04. Give the coordinates of the x-intercepts. So x-intercepts, it's at negative 4, 0, 2, 0, and 5, 0. While the y-intercept is, so where does it cross the y-axis? And it crosses the y-axis right here. This point here, that's the y-intercept, which is 0, 40. Okay. And then what else? What is the average rate of change of g of x in the interval negative 4 to negative 1? So this means that when x is negative 4, what is the value of g of x? When x is negative 4, okay, so we can look at the table. Negative g of negative 4 is 0. And then g of negative 1, so let's look again. G of negative 1 is 54. So the question is, what is the average rate of change? So how did g of x change from negative 4 to positive, to negative 1? From negative 4 to negative 1. So how did the graph change from here to here? So that means from here to here. So from negative 4 it is 0, and then negative 1, the value of y is 54. To find the average rate of change, then we want to find g of negative 1 minus g of negative 4 and divide it by negative 1 minus 4. So we just plug in the values for those, and then we calculate. Same thing here, and I will not show the detailed work. I need you to work on them on your own. let's see the bottom. Okay, so similar. Oh, here it's asking for the first difference. Okay, the average rate of change. So I am expecting we can do that. What did you notice about the average rate of change? Okay, what do you notice about? Okay, so here, h of x. So let's get started on this one. H of x, it says find h of -5. Okay, so that means the x became -5. So we just are going to substitute or plug in -5 to x. So we'll have -2 times -5 squared minus 3 times -5 plus 5. It's equal to, well, we are going to square first. So we'll have -2 times, when we square -5, it's going to be -5 times -5 is going to be 25. Then -3 times -5 is positive 15 plus 5. Then -2 times 25 is -50 plus 20. And -50 plus 20 is -30. So this means that h of -5 is -30. Find the average rate of change of h of x in the interval -3 to 4. Okay, so here we just need to find h of, because our function is h of 4, whatever that is. So we're going to find h of 4 the same way we found h of -5. Then subtract h of -3 all over 4 minus -3. Okay, and then I will not show the rest of the work. I'm expecting that you guys can do that. All right, then the last one, this is the last one here. Let's see. Yes, it's the last one. So on the last one, it says find the average rate of change of h of x in the interval -2 is less than or equal to x is less than or equal to 3. So that means that our left boundary is -2 and right boundary is 3. So it just means that we need to find h of 3 minus h of -2 all over 3 minus -2. So notice that the number that we use here is the same that we put here. So say h of 3, we have here 3, and h of -2 is right here. It's always like that. Okay.